Okay, here we go. This is AP Statistics. This is Wednesday, April 29th, 2020, which is going down as not a very good year. Okay, let's review. We are in phase 3 of our virtual learning unusual. What does that mean to you? That means I had this pattern of doing a short lesson on Monday, Wednesday, and Friday. I believe I've been told now to have only one assignment a week, and I have chosen today, Wednesday, to do that. So on Monday and Friday, I'll just check in and talk over maybe on Monday the assignment for Wednesday, and then Friday kind of a review back on what happened Wednesday. But it's only going to be that one a week, so it should be easy to get done. So the next thing I would say is if you have fallen behind or you've kind of lost touch, it is not too late to jump in and just whip them off. If I've missed you, which I did a couple of students, first of all, I apologize. And secondly, you have plenty of time to make it up. These are not, the goal of these assignments is for them to take 5-10 minutes and then boom, right back to me. So not a heavy load. Also, if I have forgotten to mark something down that you did, remember, let me know and I'll do it. People have talked to me over, I can't see my grade. The mobile app does not work for this. You have to get into a computer and click on the assignment to see whether you got it done or not. And it's P0, didn't do, P1 partially done, P2 did it. Okay, so I guess I would go the extra mile to keep you engaged, but you have to also be a willing person to do it. Okay, let's get back to the big picture here. This is an AP class which still has the testing option open. I talked to you, I don't know, some number of weeks ago, and it was about a 50-50 split. Now, time it's coming. It's Friday, May 22nd at 2 p.m. Remember, you're going to take it from your home. I don't know how that's going to work, but they, I guess, do. So you're going to do that. It's going to be a 45-minute test, and they're all free response questions, and you can use your textbook. I believe the short time is there might be some worry about people cheating, something like that. I hope not. So I think they said there are anti-cheating software, whatever that is. So people have been giving me questions lately about test setup and like that. I don't really know anything about that. Ms. Benner, Betsy Benner, in the guidance office is in charge of AP testing. So I don't know if you can do it direct or you got to contact her. I'm not totally sure of that. So that's what I would do. If I wasn't already made aware, I would check with Ms. Benner. Okay, I think that covers everything. So let's move on. From my point of view, another thing we have to talk about is our vigor is not very vigorous now. We would have, if we were really doing the exam, we'd be cracking down now. But so what I'm doing in these videos, and from my perspective, are kind of the classroom, what you would have done from a classroom point of view. So you're going to have to be doing some extra studying outside, definitely, unless you're gifted to pass this exam. And I hope you're doing that. Today, I want to talk about, last time we talked about a difference of proportions and the confidence interval that went with it. Today, I want to do something similar, only it is a hypothesis test for a difference of proportions, and just kind of work through that. Okay, so let's do it. So if you want to, if you could turn, what I've been doing on these lessons is there's an exemplar example in the book, and I just kind of work through that, and I use my own data because it's kind of fun to talk about what's going on in the world, and we all know what that is. There's really only one topic going on in the world, really, and it's this coronavirus and the COVID-19 syndrome it gives people, and it's caused world chaos. Who would have ever thought it? Okay, so if you turn in the book to an even 500, page 500, hopefully you have your calculator. We're going to do the streamline with the calculator today, but I want to hit the high points and come up with a p-value and so on and so forth. So today, we'll follow through on their example, but I want to use my own. And once again, I want to use the same type of data we used last time, which was young people who are afraid of getting the coronavirus and old people who are afraid of getting the coronavirus, and comparing those two proportions and seeing, is there any difference? That's what you do with the difference of proportion. We're going to be doing today a two proportion Z test. Okay. So I came up with P1 up here. P1 is equal to young people, and P2, no, hold it. No. I think I want it the other way though. Yeah, hold on. Let me make a change. I did not realize that. And there's a reason why later that I want it to be this way. So let's do P1 as young people and P2 as old people. And we'll call young less than 50 and old greater than 50. We won't worry. We won't be so specific as to be concerned with what. All right, we'll call old greater than or equal to 50. Okay. And let's say, so that is what P1 is. Let's say P1 or P1 hat, the sample, is equal to 30%. P2 hat is equal to 45%. Okay? Everyone with me? And then let's say that we sampled N1 500 young people and N2 600 old people. Okay? I think that's all the data setup we need. So if you'd look at with me on page 500, I will say this. Let's start with the null hypothesis. Remember, null is H-O, H sub O. Null hypothesis is P1 minus P2. In other words, the young minus the old is equal to 0. In other words, there is no difference between, no statistical difference between the two proportions. Okay, let's think about it. You know, it's always good before you actually do the statistics to do the reality check. Let's think about this situation. You youngsters think you are invincible and that you can't be hurt. That just goes with your age. We're talking generalities here, not everyone. And us older guys like me are a little more concerned that, hey, I might get that and there might be a problem here. So I think guessing, we would think there is a difference, but we're going to check and see if there's a statistical difference based on my data. So, okay, HO is there is no difference. In a hypothesis test of difference of proportion, the null hypothesis is always there is no difference, equal to 0, always. The alternative, which is there is a difference, could be less than, could be greater than, or could be not equal to. We're going to worry about greater than or less than today. So think about it. If P, that's why the young and the old, I had to rearrange them. Because they said less than. P1, young people, minus P2, old people, meaning the percentage for old people probably is going to be higher, is you subtract the two, you're going to get a negative number. Remember, order matters here with the P1, P2. Order matters in subtraction. So we subtract, will it be less than 0? And my little thought is, yeah, the young is a lower percentage, so you subtract the 2, it'll be less than 0. So there are your hypotheses, okay? All right. Following along in the book, we have the assumptions and conditions. Remember, we cannot do this 2 proportion Z test unless these assumptions and conditions check out. We're going to let them check out, but let's go through them anyway. It says random condition. All right, I went out and collected all this data. I did it randomly. I gave everybody in the whole country a ID number, and I got my little random number generator, and I came up with random data. 10% condition, yes, the 500 and 600 is well below well below 10% of the entire population. Hey, I'm looking at the camera, and I have a green dot right between my eyes. Do you know what that means? If I was a Buddhist, I'd be enlightened. I don't know if I'm enlightened, though. Okay, let us continue. The groups are independent of one another. In other words, the young people and the old people are not getting together and trying to scare one another. That would be dependence. We're looking at independence. And finally, the success failure, which ensures that the sample is not too small. And we are going to say yes, that is the case. So all of them have checked out. So now we are going to use our calculator to come up with a p-value. Remember before with a hypothesis test, p-value is what you use to make your decision rather to accept the null hypothesis that there is no difference or to fail to no. Let me go back to that. All right. I don't want to beat you off here. The original thing is we assume that the null hypothesis is correct. So if we don't have data to overturn it, we are going to fail to reject. We're not going to accept. That was wrong wording on my part. Fail to reject. And then if the p-value is what? High or low, we're going to reject. When P is low, reject HO. When P is low, see, I even got a little rhythm. When P is low, reject HO. And what for us will be low, will be less than 5%. Okay, less than 5%. And you can see how it is done by hand, but that is very kind of messy computation that we are not going to get into today. We're going to use our calculator. Okay, so that is what we're looking at. So if you get your calculator and go to stat and then over to tests and down to 6, 2 proportion Z test. And it says X1 X is they want to know not the percentage of people, they want to know the number of successes. So all you have to do is you can do the little math right on that line there. You can go 0.30 times 500. And I get 150. So 150 should be on your X1. Then I go down to N1, and I already said that was 500. That's good. X2, I can go 0.45 times 600. And that comes out to be 0.40. Oh, hold it. 0.45 times 600. And that's 270. Okay. So the four, let me review. X1 would be 150, N1 500, X2 270, N2 600. Then we said that P1 and P would be less than P2. So highlight P2. Then we go down to calculate, and we could have a drum roll, please. And wow, you look at the third statistic down, it says P equal to 1 point. Oh, well, all right, I'll do it all. 7119164 e to the negative 7. Is that low? Yeah, that is incredibly low. Incredibly low. Okay, P is low. What are you going to do when P is low? You're going to reject the null hypothesis that there is no difference, and you're going to accept the null hypothesis that the percentage of young people who are fearful of getting the coronavirus is much less. We're going to go even further and just say there isn't evidence. There's strong evidence. And why can I say strong? Because of how low that is. All right. That is incredibly low. So our final, if you look over on page 502, is giving you what the p-value means. If you look down and read that, it tells you how often this would occur if this data showed up. It would be incredibly rare, But so because it is so incredibly rare, we are going to say there is statistical evidence that young people are less anxious or less worried or scared, or whatever you want to use for the word, less worried about getting the coronavirus than old people. Does that data make sense? Yes, it makes sense. It makes a lot of sense. Okay, so what I'm going to do now is change some of these numbers up, and I would like you to do the same thing for me, okay? And send it along to me. So let's do the change. Let's change. We're going to keep old and young the same P1 and P2, but we will change P1. Let's make it a little closer so it isn't so blatant here. Let's change P1 to, we'll change it to 40%. And we will change P2. You know what? I think that could be, let's not change P2. Let's keep them right about that. And let's just I think this will alter the problem enough so we might have some different results. Okay? So what I would like, and we'll keep everything else the same, I will erase. You obviously will get a different p-value. So what I would like you to do that you can send on to me is to give me your null and your alternative hypothesis, like I have up there. Give me your p-value, what you came up with a p-value in the end, and then what that means. What's your decision with the p-value, and kind of put it in the context of the problem, if you would. Okay, I think it's a great problem. I really do. So remember, we only got one problem this week. We don't have three. We're only doing the one. So you should be able to get it in no problem. So I think that's it for today. So I think on Friday, rather than doing a video, I'm just going to do kind of an email saying, get in, check in with me with the answer. And then I will see you on Monday. Monday, we're starting a whole different Monday's. Actually on Monday, I think I will kind of give the lesson and do the problem on Wednesday, because we're switching gears. We're moving away from Z to the T distribution. We've been doing Z all year, so we're going to do something new. We're going to do T, and we will do that on Monday. Okay, I think I've covered everything, but give me an email if you have any questions. And like I said earlier in the week, on Tuesdays, there's supposed to be an open, if you ever wanted to hang out, Google Hangout, we could do that. I think that's it. So you have a good day, and I will see you later.